All right, here's the application problem for Module 5, Lesson 6. Let's read this together. It says, a storage company advertises 3 different choices for all of your storage needs. The cube, a true cube with a volume of 64 meters cubed. The double the volume of the cube. And the half, which is half the volume of the cube. What would be the dimensions of the 3 storage units? So part of this is cut off, and I will change the 3. What could be the dimensions of the 3 storage units? Question mark. And how, the last question is, how might they be oriented to cover the most floor space? And then it says the most height. So there's a few things that we're going to do here. Okay, so a storage company has 3 different choices. They have a cube, they have the double, which is double the volume of the cube, and then they have the half, which is half the volume of the cube. So what can we draw? Let's draw the cube first. The cube has a volume of 64 meters cubed. So when we draw our cube, remember a cube means it has the face of a square, which means that all sides are equal, right? All sides are equal. So here's our cube. And 64 meters cubed is the volume. So each side, if they're the same, is how many meters? What times what times what is 64? 4. 4 times 4 is 16. Times 4 is 64. And remember that this is meters. Okay? So, this is the cube. The double is double the volume. So double this volume, if you double it, 64 times 2 would be what? So the double is 64 times 2, which is 128 meters cubed. And then we have the half, which is half of 64. So 64 divided by 2, which equals 32 meters cubed. So I'm going to highlight. We have the double, that's 128. The half, that's 32. And we know that the cube is 64 meters cubed. So those are all of our volumes. So what could be the dimensions of the 3 storage units? So the cube dimensions could be 4 by 4 by 4, right? The double, we have the total volume, but the dimensions could be. So if we were to double this, that means we're going to stack a cube on top, or we're going to stack another cube to the side, right? So a double, then, if we added another cube, and you can do this on tap-tap blocks, but if we add another cube to the top, our height would change, right? But would the length and the width change? No, they wouldn't. So we would have a length of 4 meters, a width of 4 meters, and then we would have a height of now double of 4, which would be 8 meters, which still gives us 128 meters squared. So that would be the most height, right? The most height. The most floor space means that you would lay another cube next to that one. Which you could get 8 meters times 16 meters, okay? But this is just asking what could the dimensions be. So here's an example of one of the dimensions for the double, and then another dimension for the half would be that one of the sides we would just cut in half. So we could have a length of 2 meters times 4 meters width and times 4 meters height. So this could also be another dimension, which is 2 times 4 times 4, which would be 32 meters. And then it talks about those are dimensions that we could have, so that's answering that first question there. What could the dimensions be of the 3 storage units? Those are the dimensions. And then how might they be oriented to cover the most floor space and the most height? So when we talk about the most floor space, you can do this on tap-tap blocks. But if you were to create a storage unit with the volume, I'm going to change this to blue, with a volume of 128 meters squared, to cover the most floor space, you could do a base of 128 meters and then a height of just 1 meter, right? That would cover a lot of floor space. So 128 meters squared times 1 meter height. That would be the most floor space. And the most height for 128 would be the opposite of that. So instead of wide, long, lengthways, we would go 128 times 1 times 1. So 128 would be the height, 1 would be the length, and 1 would be the width. For the half, the floor space, we have to have 32 meters. Okay, so 32 meters is your total volume. We would do pretty much the same that we did for the double. So it would be 32 would be the length. Whoops. 32 meters squared is the length, and then times 1 meter high. So 32 times 1 meter high. And then the most height, you would have, your height would be 32 high times your width of 1 meter times your length of 1 meter. So those would be your dimensions. A lot that just went into this one application problem, but think about using those tap blocks.